Hi everybody. Here we are in the middle of the weekend. A lot of people are still working on question 0, which is quite a bit behind where I think you need to be. You want to be at a point at the end of next week, not just that you're done with all your problems, but you need to be able to know you can think clearly enough about these problems you could do a new one in about 10 minutes without too much struggle. So this sounds like a practice situation. So in this video, I'm going to do a walkthrough of the solution, and I'm going to recommend some simpler practice exercises you can do to work on the pieces separately so that you will know that you can do these problems. As a reminder, here's the first problem that we had. We're supposed to output a table where something in the table is changing, and then we're displaying either an average or a probability as the other value. So in this case, we have some number of random steps, and then the value that's related to that is the average displacement if I took that many steps. Okay, let's jump to code. There's 3 parts to this, and you could do them in any order. So you could think, I'm going to display a table, but I need to know how to get the average displacement, and that's going to be finding an average that combines the outcomes of thousands of trials. And then how do you do a trial? That's one simulation. So you could start by displaying the table and then think, okay, how am I going to get the average? And then, okay, how am I going to do the simulation? I think for most students, it's easier to start the other way. Think about what is the action that needs to happen, then run that action over and over again to get the average result, and then put those average results into a table. So let's do it in that ordering. So I'm going to write do one simulation. And this is going to take random steps. So I'm going to create the method. Okay, so what am I trying to do? I know I'll need an X position and a Y position. I'm going to take some number of random steps. Up to what? Well, I'm not sure. Let's just do 10 for the moment. So I'm going to have a direction that's going to be one of 4 possible directions. So this gives 0 to 3 as the possible directions. And I'll say if direction equals 0, let's have that be go right. So I'll add to the X coordinate. If the direction is 1, we'll have that represent going left. If the direction is 2, we'll have that represent going up. And if direction is 3, we'll have that represent going down. Great. So now I'm looping a bunch of steps. I get a random direction, and I adjust my end position. What do I care about at the end? Once I've done 10 steps, what is it that I wanted to measure? I wanted to measure my ending distance, so I'll need the distance formula, which is math.random of the x coordinate squared plus the y coordinate squared. Okay, so there's only one thing wrong here. It says, well, what it says isn't that helpful. It says expected 0 arguments but found 1. And what's happening is we have a void method. So I'm going to have it return a double because it's supposed to return that distance. What is it not like now? Oh, I did math.random, excuse me. Math.square root is the distance formula. Okay, great. So I'm doing a simulation. The only thing that maybe is a little bit weird is I'm only taking 10 random steps. So let's fix that. If I'm going to do a simulation where I need to take different numbers of steps, it seems like that number of steps should be an input. So instead of saying let's do 10 steps, let's take it as an input, and then whoever does the simulation says, well, let's do 10 steps, or let's do 20 steps, or let's do 30 steps. Okay, so we can do that. And if you wanted to, you could test it. We could just print out the results of doing the simulation. Let's say doing it for 2 steps. And we could do it in a loop that's just going to print it 10 times. Not because that's part of the problem, but it's just nice to see what happens. It'll let us see if we're getting results that are totally insane or not. So here's the outcome I got. These don't look totally insane. It might happen sometimes that I'd have a total distance of 0 if I took 2 steps, because I could step out and back. It makes sense that sometimes I'd have 2, but no more than 2, and it makes sense that sometimes I'd have something in between. So all this makes great sense. Okay, so now that I can do the simulation, how do I find the average? So that's going to be its own method. Find average displacement. Let's create this method. You could call it find average end distance. And now I'm not thinking about like, what am I doing? Am I taking steps, whatever? All this does is finds the average. So if I had a whole bunch of numbers and I wanted to find the average, let's like loop a whole bunch of times. And to find the average, I have to add a bunch of things up and then divide by how many. So I'm going to have a sum, and I'm going to say sum gets whatever the next number is. And then at the end, I would return sum divided by how many. So this is the general pattern for finding an average. We need to fix the return value again. Where does the next number come from? What are the numbers that I'm finding the average of? I'm trying to find the average of the ending distances for each time I do my simulation. So I need to run do one simulation. But it needs to know the number of steps. I could just give it 10 again. And so now this would be a great way to find the average ending distance when I take 10 random steps. But again, I want this method to be flexible. I don't just want to take 10 steps, so let's give it an input. Let's have this one take a number of steps also. So here's num steps. Great, so now it's going to loop 10,000 times, and each time it loops, it's going to take however many steps it's supposed to take, and we add up all those ending distances and divide by how many to find the average. So far we've got a method that does the action, then we've got a method that finds the average outcome whenever we do the action. Now let's do the one that displays a table. It's easy to display a table. Let's have rows that go from like 1 to 10, just for example. And if I wanted to display a table, you could do something like this. You could say, let's display one row at a time. So I'll say row, and then an arrow, and then an arrow. And then if I wanted to display like the table that's x squared, so this is like the x value because it's the first number. This is the y value because it's the second number. And so if I display this, you see it's displayed this nice table with x values and y values. The thing is, this y value, I don't want it to be the x value squared. The y value is supposed to be my average displacement. So let's do this, find average displacement. It needs to know an input that's the number of steps. Oh, but the number of steps is just whatever that first row number is. So I can pass the row number as however many steps I want to find the average displacement of. And so now I can run it again. And now it's giving me my outcome. And then if I don't want to go to 10, maybe I want to go to 50, I could do that. So this is now a complete solution. And if you wanted to, you could put this inside its own method, display table up to. So this method is going to display a table, and then the input is like the max rows or something. And so I just pasted the code I have. And so now I'm going to go from 1 up to max rows. So now I really have one method that does what I want. The one method displays the table. The way we get the y values from the table is by finding an average here. The way we find an average is by doing the simulation over and over and over again and adding up the outcomes and dividing by how many. And then the simulation is where we actually take the steps. So that's the subdivision that you want to practice. It's useful to be able to do this whole process all at once. If you feel like one step of this is confusing, like the warm-up, we just did this middle layer. So you could do practice problems that were just finding the average, where you run a method that you don't think about how it works. Or you could do practice problems that were just displaying a table, the way that I did row times row. Or you could do problems that are just performing some simulation where you don't worry about the average or a table. You just worry about what's the action that needs to happen, and then how do I return what I care about at the end of the action. Okay, come back next video and we'll solve one more problem that's about probability.